In this example, I'm going to show you how to turn the values of a, b, and c into decimals. I'm going to show you how to use the Inspire calculator and also Desmos. So if you use Desmos, you're going to go to desmos.com, click the graphing calculator. And it's as simple as typing in your different values here. You could use the keyboard if you don't have a keypad on a phone or a laptop. And there you go, 19 over 20 will kick you out a decimal 0.95. So then you're going to click down here to get a new entry line, type in the other fraction. And there you go, you have 1.6666 that goes on repeating. Click another entry line to type in the square root of 15. And there you have it, it's roughly 3.87. And notice as I wrote my numbers, right here we've got 0.95 because it's the exact value. This is the exact value as well when I have it set equal to 1.6, but it's got a bar over it. That bar means that that 6 was repeating constantly forever. And then the squiggly equal sign means an approximation. So I rounded this one to 3.87. In this example, I would like to demonstrate the use of a number line. And you can see all these points graphed on a number line with the different values assigned to it. So let's take a look at f. F is roughly right between 200 and 300 right here. It's not quite in the middle, so that's why I have it listed as 245. If you look at point E, E is just past 100, so that's why I have it listed as 105. If you look towards the negative values, you could take a look at A. That's almost to negative 300, but it's not quite. So that's why I have it listed as negative 290. And the same thing with like B. It's just past 200, a negative 200. So I have it listed as negative 225. In this example, we'll actually graph some values on a number line. So here for A, we have 3.2. So we will find 3 right here, and 0.2 will mean it's just past 3. Label that as A. B is negative 7.5, so it's down here with the negatives, but it's getting smaller because it's a negative value, so it's going to be somewhere between negative 7 and negative 8 right here. For C, you're going to want to turn negative 3 over 2 into a decimal form. You could use Desmos or the Inspire if you don't know how to do it offhand, but that's going to be equal to a negative 1.5. So we have to go over here by the negatives, past negative 1, and we'll graph that as a negative 1.5. And then lastly for D, again, turn it into a decimal, and that's going to be exactly 2.25. So we go up here with the positive values, and we can go anywhere just past 2, and we'll label that one as D. In example 3, we have a little bit more work with number lines. Part A says the number line is divided into how many pieces? Well, you've got, I'll do this in color. One section here, that will be our first piece. We have another section here, that will be a second piece. Another section, that will be a third piece, and then when we go to this last section, that's your fourth piece. So you have 4 basically parts of this number line. So if we write this as a fraction, it'll be out of 4. And then how many pieces down do we go to get to A? So this is the first, the second, the third. So it's going to be 3 out of 4. That will be the location for point A. Example 4 is going to be a little bit more work. So first we have to figure out how many sections we have. So again, this is the first section, the second, third, fourth. So we have 4 sections. So it's going to be out of 4. All right. And then A represents we've gone past 1 part. B will be going past 2 parts. And then C, that will be going past 3 parts. So that would represent 3/4. For this example over here, we got to figure out, again, how many sections we have. So 1 section, 2 section, 3, 4, 5 sections. So that's going to be out of 5. get rid of these. So then how far did we go down to get to D? This is 1, this would be 2, so D will represent 2/5. E will represent 3/5, and then F will represent 4/5. And if we went all the way to this one right here, that would be the fifth one. That would be 5/5, 5 over 5. That's just equal to 1, which you'd see on the number line. In this example, we want to mark the location of 1 over 8. So we could kind of assume that there's going to be 8 sections here. So 1, 2, 3, 4, 5, 6, 7, 8. Yeah, we confirm that. So we want to mark the location of 1 out of 8. So then that would be right here because that's the first tick mark out of 8 sections. So that will be 1 out of 8. This one over here is a little bit different because we have a full number here and another full number, or a whole number here. So we have 1, 2, 3 sections, and you could see that represented by the denominator. But we want 2 sections down. So this is the first tick mark, and then the second tick mark. This right here will then represent 2/3. Example 6, which letter best represents the location of 1.1? Well, it's going to be just past 1, right? So the only one that's just past 1 is going to be D. So we'll go with point D there. Which letter best represents the location of 0.66? So 1/2 right here is the same as 0.5. So then if we have to go a little bit past that to get to 0.6, that's going to be B right there. So that point will represent 0.66. If you're thinking, well, what about C? Well, halfway between 0.5 and 1, that would be 0.75. So C would be a little bit more than that, which we don't want. We want to stay at 0.66. In this one right here, which letter best represents the location of 0.8? So 0.8 is going to be before 1. So the closest one I'd say would be C. B would be too close to that, 0.5. B would be more like 0.6. So A will be C. And then B right here, which letter best represents the location of 0.08, that's really, really close to 1. So, I'm sorry, very close to 0. So we're going to go with the letter A there. In this example, we're going to be working with inequalities, and I refer to Pac-Man. Pac-Man always wants to eat the larger number. So, for example, A, of course, 8 is the larger number, so we open up to the right because we want to eat A. That would be the correct inequality symbol. For B, of course, 11 is the greater number, so then I open up to the left. C, we've got a negative, so now, of course, 2 is larger than a -5, so we open up to the right. D, again, we have a negative number. Even though 31 is larger, like a positive 31 is larger than 20, it's a negative number, so it's going to be more negative. That means it's going to be smaller, much smaller than 20. So we want to eat the number 20. For -12 and -16, we got 2 negative numbers. Of course, 16, positive 16 is bigger, but because it's negative, it just means it's a much smaller number. So it's going to be smaller than a -12. So I want to eat the -12 because it's not as negative as -16. For F, we've got 4.8 and then 4.82. Think of it as this, 4.80. You could always put an unlimited number of zeros to the right of it. But to compare them a little bit easier, let's just stick with 1 0 after the 8. So that's going to be like 4.80. And if we compare that to 4.82, then it's much easier to see that 4.82 is going to be the larger number, just by a little bit. And we could do the same thing with G here. This one's got 2 digits here after the decimal, so we could stay with 1.50 and then compare that to 1.05. So of course, 0.50 or 0.50, that's going to be much bigger than 0.05. So we're going to eat up the one on the left. For H, we've got the positive number here on the right, so of course we just want to go with the bigger number there. And then for this one, I, we've got fractions, and it might be tricky to see which one's bigger here. I would go back to the Desmos app or the Inspire calculator and turn these into decimals and figure out which one is bigger from there. So over to Desmos I go. We had 23 over 61. So that's going to be 0.377. And then we also had 11 over 18, which is 0.61. So of course 11 over 18 is going to be larger, so we're going to eat that one up. Now I'm going to explain a little bit about rounding. Rounding is the process of approximating a number to a certain value. So imagine if we had a big long number here. You have all these digits and then a decimal, and then you might have some digits here. Each one of these spots, we have 56,710.0189. Each one of these spots is a value. So the 5 represents the 10 thousands column. The 6 is the thousands, and then to the right of the decimal, we've got the tenths, the hundredth, and the thousands, and so on. So we're going to use that chart a lot when it comes to rounding. I've got some examples of rounding here. And now we have some examples. We want to round to the nearest 100. So what I like to do is I underline the hundreds column. You could refer to this diagram right here. 100 is right here. It's going to be the third digit to the left of the decimal. So this is going to be the 100. And I always look to the right of the 100. If that number is 5 or more, we make this number here larger. If it's less than 5, we let it rest. So because 4 is less than 5, we're going to keep it as 93,200. And that's rounded to the nearest 100 spot. Example 2, we want to go to the 10,000s. So I underline that one, and I could refer to my table here. 10,000s is going to be this one. It's the 5th digit after the decimal, so that's going to be this one. I underline that. I look to the right of it, which is a 6. In this case, 6 is greater than 5, so I'm going to round 5 up to the next number. So that's going to be 860,000. Example 3, round to the nearest dollar. So in this case, the dollar spot is a little different. You wouldn't necessarily refer to this column. The nearest dollar is going to be this one, the 6th. So I look to the right of that, which is a 5. So whenever, again, it's 5 or more, we round up. So that means I've got $47. Example 4, we round to the nearest tenth. So now we are looking to the right of the decimal. So to the right of the decimal, we've got the tenths column. That's the first digit to the right of it. So that means we underline this one, and I look to the right. Since it's 5, we're going to bump that 3 up to a 4. So that's going to be 4.4. We don't write anything else after it. Example 5, we round to the nearest hundredth. So this is going to be, I'll do this in a different color. This is going to be the hundredths column, is the second digit to the right of the decimal. And I look to the right, it's a 5, so I'm going to round that 9 up. So the next number that would come after the 9 actually would be a 0. But then that means we bump up the next one 1, 2. So that final value is going to be 0.70. So the 9 goes up to a 0. But if that happens, if we ever get to a 0, then you have to bump up the one to the left by 1 as well. An easier way of thinking of it is, imagine if you had the number 69 here, and that 5 means we bump up this one to a 0. The next number up from 69 is going to be 70, so it's going to be 0.70. And then example 6, we want to round to the nearest thousandths, so that's going to be this column here, the third digit to the right of the decimal, so that's going to be a 9. We look to the right, which is a 7, so that means we want to bump it up. So then this becomes a 0. Then this one we need to bump up as well, which would have to be a 0. And then that means we have to bump up this one more. So that's going to be a 4. So then the final value is going to be 65.4 essentially. And you wouldn't even have to necessarily, well, yeah, it's probably good to keep the 2 zeros as well, but that would be the same as 65.4. And again, another easy way of thinking of this, if you're going to look at that 7 and be like, oh, okay, I have to bump up that 9, well, think of it as 399. What's the next number above that? That's going to be 400, which is what we've got here, 0.400. So estimating, it's the combination of rounding and carrying out an operation. So in this case, we are estimating 64 to the nearest tens, I suppose. So that would round down to 60. 55, since it's a 5 at the end, it's going to round up to 60. And when you add them, you've got 120. So in this case, if we were going to round to the nearest tens, 29, that's going to bump up the 2. Well, I guess if we're going to round to the nearest tens, I should underline 2. I look to the right of that, which is a 9. So that's going to be 30. And then here, I look to the right of the 3, which is 8. So we're going to bump that up to a 40. 30 plus 40 is 70. And then in this case, we look to the right of the 2. It's an 8, so we bump that up to a 30. Here, we look to the right of the 5, which is a 6. We're going to bump that up to a 60. 30 plus 60 is 90. Example 2, you've got a word problem here. Mary's earned $25, and she wants to buy the following items. We want to estimate all these to the nearest dollar and add them up. So the nearest dollar would be here. So I look to the right, which is an 8. So that's going to bump up to $1. We've got $6. I look to the right of that, which is a 0. So I stay at $6. And then there's dollar here. We look to the right, which is a 9. So we bump that up. That's going to be $12. So if we take 1 and add it to 6, that's going to be $7. If we take $7 and add it to 12, we're left with $19. So can Mary buy what she needed to buy? Yes, she can. In example 3, we want to first estimate, and then we're going to find the exact value. So we will take